In this video, I'm going to go over two different examples. While in the first example, I'll go over how to divide polynomials using polynomial long division. In the second example, I'll go over how to divide them using synthetic division. Let's jump right into it. Alright, so here's our first problem. And we're going to set this up the same way we've done long division with just regular numbers. And we're going to go ahead and set up our long division. This right here is our dividend, which is always going to go inside here. And this will be our divisor. And we're going to put that right over here. Next, what I'm going to go ahead and do is just separate this into each of our terms where we have our degrees. So notice that for our dividend, we have this third power inside here, then we have this second power, then we have this 14x to the first power, and technically we have a 20x to the 0th power, but let's not worry about that. And then on the outside, we have this 2x, and I'm going to raise that to the first power. So I just like seeing all our exponents. Alright, this next part is optional, but I like drawing in these vertical lines just so I can stay organized and make sure all my exponents are in the right locations. Alright, now that we have everything set up, let's go ahead and get started with the long division, right? So the first thing to notice is this first term, and that's the most important one we're going to start with. We have to see what we multiply this first term on the outside to match this first term on the inside, right? Now if you think about it, if we're trying to get this 2x to the first power and multiply by something to equal this 2x to the third power, well, we already have this 2 and 2, which is really nice, so we don't have to multiply by any specific number, but there's only one x here and there's 3 of them over here, so we need to multiply this by x to the second power, since x to the first power times x to the second power will add up to being x to the third power. So this is what we're looking for, x to the second power. Now, when you're trying to decide where to put that x to the second power, that's going to go right in the column that has all of our exponents that are raised to the second power. So let's go ahead and say this is going to be 1x raised to the second power. All right. Now, what we're going to do with this x to the second power is we're going to multiply it by this first term over here. We're actually going to distribute it to both, but let's just do one at a time. So when we take this x squared and multiply it by 2x to the first power, that's going to equal 2x to the third power. So I'm going to go ahead and write that right underneath this first term, and it should always match it identically if you did it right. Next, we're going to take this x squared and multiply it by this negative 4. So x squared times negative 4 is going to be negative 4x squared. So let's go ahead and write minus 4x to the second power. So notice how all our exponents are lined up here. We have 2, 2, and 2. Notice how we have our exponents lined up with 3 and 3 here. All right. Next, what we're going to do is give this row a hug. Always put parentheses around here, and then let's go ahead and subtract these two expressions from each other. All right. Each time we subtract, if we did a good job, these will cancel out because they are identical. And then if you take this negative 6x squared and you take away this negative 4x squared, that's the same thing as adding 4x squared. We're going to end up with negative 2x raised to the second power. All right. So just go ahead and double check that, but if you go ahead and take away a negative, from that negative you end up adding instead. All right. Next, what we're going to do, just like in regular long division, we're going to take this 14x to the first power and just bring it on down. So it's positive, so we're at plus 14x raised to the first power. All right. All right, now let's go ahead and repeat the same process that we did earlier. So earlier we tried to match this 2x to the third power. Now we're just going to do this whole thing over again and match this negative 2x to the second power. So the question we're trying to ask is, what do we multiply this 2x to the first power to match this negative 2x to the second power? So we're taking a look at this 2x to the first power, multiplying by something to get this negative 2x to the second power. Now if we take a look at the 2, what does 2 multiply to become negative 2? And that's going to be negative 1. And then what will we multiply x to the first power by to get x to the second power? Well, that's going to be x to the first power, right? Because if you use your rules of exponents, x to the first power times x to the first power is x to the second power. So we want this negative x, or this negative 1x to the first power. I'm going to go to the top here and write minus x to the first power. All right, that was the piece that we're looking for here. If you just want to double check that this works, we can do it when we are multiplying by our divisors. So if we take this negative x squared and multiply it by this 2x to the first power, notice how that's going to be exactly negative 2x to the second power. And then if we take this negative x to the first power, multiply it by this negative 4, that's going to be a positive 4x to the first power. All right, so that's what we're going to get here. Just like earlier, we're going to go ahead and give this a hug. Let's put some parentheses around here and then subtract to see what our remainder is going to be. Now, if we do that, these are going to cancel out with each other because if you take away the same thing from itself, then it's going to equal 0. And then if you take this 14x to the first power and take away 4x to the first power, that's going to be 10x to the first power. So I'm going to go ahead and write 10x to the first power here. All right, now that we've found our remainder, what we're going to do next is just bring down this minus 20, just like we did earlier, and then we're going to repeat the whole process one more time, it looks like. So earlier we got things to match this 2x to the third power, then we got things to match this negative 2x to the second power. Now we have to try to match this 10x to the first power. So the question is what are we going to multiply this 2x to the first power? So we get this 10x to the first power. So let's think about if we have this 2x to the first power multiplied by something is equal to 10x to the first power. So this 2, what is 2 going to multiply to get 10? That's going to be a 5 here. And then for this x to the first power, what are we going to multiply to get to x to the first power? Well, you don't have to multiply by anything because it's the same. So we just are looking for a positive 5. So up top here, let's just go ahead and write plus 5. And let's just distribute this to make sure it works. So take this 5 here and multiply it by 2x to the first power. That is going to be 10x to the first power, which is what we were looking for, so that's good. And then this positive 5 times this negative 4 is going to be negative 20, so we can go ahead and write minus 20. So notice here, everything seems to match actually perfectly, so we're not going to have a remainder, which is good news for us, so it's less work. Let's go ahead and subtract these from each other. And surprise, surprise, we see that our remainder here is just going to be 0. So there's not going to be a remainder in this problem. So going back to the original problem, if we want to see what our quotient is, or the answer to this problem, we can see that's going to be what we have at the top of our division. So this is going to be equal to x squared minus x to the first power, or just x, and then plus 5. This will be the answer to this division problem. And for good measure, if you just wanted to check, you could take this answer we have and multiply it by this 2x minus 4, and you will get this original 2x cubed minus 6x squared plus 14x minus 20. So while there you have an example of dividing polynomials using long division, here's an example using synthetic division. All right, so in this example, we have 10x cubed minus 12x squared minus 7x minus 18. We're going to divide this by x minus 2. Now, while I'm going to go over this using synthetic division, feel free to go ahead and try using polynomial long division to make sure this works as well, but totally up to you. So if you want to pause this, you can also give it a try if you want to. Now, when we perform synthetic division, it's going to be definitely a lot less writing to do, but you have to make sure you know how to use the algorithm or know which steps to take here. So first things first, you want to make sure you have terms with all the degrees going down in order. So we have to the third power, to the second power. Technically, we have to the first power, it's just invisible. And then we have x to the 0th power here, but that's just what that implies when we have a constant at the end. So everything looks good here. Next thing we're going to do is just notice what our coefficients and constants are. So we have 10, we have this negative 12, then we have this negative 7, and then we have this negative 18. All right. Now the other thing we want to do is take a look at this value over here, or this binomial, and see what makes it equal 0. Now what makes this equal 0 is going to be the value x equals 2. All right. So once you identify that, we can go ahead and set up our synthetic division. So the 2 is just going to go over here on the side. Right, that's always going to be what we put on the side in this little corner or in this little box, however you want to write it. And you go ahead and write our coefficients and constants down from left to right here. So make sure you have each degree accounted for. In this case, they gave us all of them, which was really nice. And then we can go ahead and just leave some space and then just draw a line underneath here. So this is always what the setup is going to look like. So again, just identify what makes this divisor equal 0. In this case, it's 2. So that 2 is going to go over here on the side. And then just make sure you have all our degrees going down 3, 2, 1, 0. And that's going to be all the values that we put right over here. All right, so let's get started in the actual algorithm. So we're going to bring this 10 straight down. That's always going to be the first step. Just bring it straight down. Then we're going to take this 2 on the side, multiply it by 10. That's going to equal 20. So let's go ahead and put a 20 right underneath this negative 12. All right. Next thing we're going to do is we're going to add this column together. So negative 12 plus 20, that's going to equal 8. Let's go ahead and write that right over here. Then we're going to take this 2 and then repeat the process, multiply by 8, and that's going to get us 16. So I'm going to go ahead and write a 16 underneath this negative 7. Let's go ahead and add these together. Negative 7 plus 16, that's going to equal positive 9. And we're going to repeat the process again. So 2 times this 9 is going to be 18. So it's going to put 18 underneath that negative 18. And if we finally go ahead and just add these last two numbers in this column, negative 18 plus 18 is 0 here. So right here, what we've identified is this would be the remainder. division problem. And what we have for the numbers over here, these are actually our coefficients for our answer. So what we know the last one is, this 9 is going to be just a constant, so that's going to be x to the 0th power. This is going to be x to the 1st power, and this is going to be x to the 2nd power. So I recommend just going from right to left here, but this last one on the right is always going to just have no x value because it's x to the 0th power. Then this is going to have an x, this is going to be x squared. So what's our quotient or our answer going to look like? Our answer is going to be 10x to the 2nd power plus 8x plus 9. This right here would be our answer to this division problem. And again, just for good measure, if you wanted to check to see if this was right, you could take this answer here, multiply it by this x minus 2, and you will get this original dividend that we had from the beginning here, right? Hopefully that makes sense. If we take this whole long thing and divide it by x minus 2, and we get this as our quotient, then if we take our quotient here and multiply it by this x minus 2, we'll get back to the original expression that we started with. All right, so there you have two different examples of using polynomial long division and synthetic division. On the one to the left over here, we did this by using polynomial long division. If you want to go ahead and try this using synthetic division, see if you can get the same answer. And then on the right here, we did this one using our synthetic division. And if you want to use polynomial long division to see if you get the same answer, that'd be a cool way to see if you really know how they both work and if you can use both of them to get the same answer. Alright, that just about wraps up this video. If you found it helpful, please let me know in the comment section down below. And as always, keep up the great work that you're already doing.